BIOS. In this nugget, we talk about the BIOS, and we start off by talking about some of the common terms that you might see in various documentation and in conversation, like the BIOS itself, or CMOS, or some of the other terms. We also take a look at the various BIOS functions. What's it good for? Why do I need to use it? What kinds of things does it configure? And then we'll talk about actually configuring that BIOS and saving its settings to the CMOS. I don't know what I spelled in here, but that's supposed to be an ING over here. Anyway, then we'll also take a look at some example screens. Of course, I can't run software while I'm booting to my own BIOS because there's no programs loaded then. But I did take some photographs of some BIOS settings that you might be interested in. And then we also took a look at, I don't know what's gone on with my spelling here today. We also will take a look at some troubleshooting issues so that you can identify ways to get into deep troubleshooting of the BIOS and or the motherboard itself, really, if you need to. You know, a few summers back, I decided to buy my first SUV as a symbol of my success. And I put the kids in the car, and we were going on a family trip, and it was the middle of August when this was all going on. And here in Phoenix, Arizona, it can get to be 110, 115 degrees, so extremely hot. Well, we were driving on this trip, and my kids in the back started saying, "Daddy, it's getting hot back here." And I said, "Oh, quit your belly aching, kids. It's not hot. I've got the air conditioner on full blast. This is a brand new vehicle. I'm sure it's just fine." Actually, it is getting kind of hot in here. And I felt the vents, and not only was the air conditioner not working, but the heater turned on automatically. It turns out that, at least this is my best guess, the manufacturer determined that when it got to a certain heat or a certain temperature, they would turn the heater on to siphon heat off of the engine. They did not account for the kind of heat that we get here in Phoenix, Arizona. Well, thankfully, I don't have that vehicle anymore. The manufacturer was never able to correct the problem. But that was definitely some programming that went very much awry on that vehicle, and I don't know if they've ever resolved that. And certainly in your systems, you need to do basic programming in a certain sense to make sure that the computer runs properly, and we do that through the BIOS. So let's talk about the BIOS and a few of the associated terms just so that we can make sure that we kind of get things straightened away here. First of all, what is the BIOS? This is just an acronym that stands for Basic Input Output System. And this is something that we also kind of refer to as a piece of firmware, which sometimes people kind of colloquially refer to as software on a chip. That's kind of what firmware is. So anyway, that's what this is. This is where the programming of the base operating system of the computer comes from. And I don't mean operating system like Windows or something like that. I mean in a more basic level than that, because there is still some small level of an operating system that goes on when the computer is turned on and you are able to configure it. Also, a lot of this stuff is stored in read-only memory, and it's loaded from read-only memory very often into RAM so that you can have something to work with. Then we also will have another term you might have heard periodically, called the CMOS. This stands for Complementary Metal Oxide Semiconductor, another acronym. And basically what this is where you make changes in the BIOS, and the BIOS settings, they get stored into the CMOS so that you can retain those settings that you've made from one boot to the next, and even after a power off. This again is where that battery is important, because if the battery ever dies, that we've referred to before on the motherboard, then you will lose all those settings that you've made, and you might have to go back in and rejigger the whole thing. But colloquially, we'll just kind of refer to the BIOS and the CMOS in conversation, at least, kind of synonymously. We'll say we need to configure the BIOS, or we need to configure the CMOS. And that basically means working with the BIOS that's been presented to you and making the changes in it through a series of menus so that you save it out to the CMOS. Now let's also talk here about some of the basic functions of the BIOS that we have here. What does it do? Well, the basic function of the BIOS is to detect and configure various components that we see down through here, such as storage. This could include your hard drive or your floppy drive. It could be your DVD or CD drive, all those sorts of things. And in fact, now with more current systems, it'll even detect USB flash drives, also known as thumb drives or memory on a stick or something like that. So it detects all of those types of storage. And of course, it has to identify that in order to at least load an operating system. So for example, if you're inserted the Windows DVD into the drive, it has to be able to see that so that it can then boot from it and you can start to install Windows. Or once Windows is installed, it has to be able to see the hard drive and the operating system on that hard drive. So you can see where the BIOS gives us an essential level of detection so that you can work with an operating system and actually do something with your computer. Then we also have memory configuration and detection, and also our cache. With these types of things, and by the way, I'm going to show you most of what I'm going to show you in these whiteboards. I'm going to show you that in the actual BIOS menus here after a little bit as well. But this will identify how much memory you have, and it can detect that. It can also do testing of that memory during the post, which we'll talk about a little bit later here as well. There's also cache settings that you can adjust as necessary. But I find that unless you're doing overclocking, which is a way of kind of juicing up the system so that it performs beyond its initial spec, then you don't really need to mess with the memory or the cache very often. They usually work pretty well on their own. Although with some advanced BIOSes, like the one I'm using on my Asus motherboard, there's actually a button on the motherboard that you can press that will automatically fine-tune the timing and the operation of the memory so that it will be maximum compatibility. Especially with memory modules that we have today, they're very, very sensitive and because their timing is so specific. We'll talk more about memory at a later time. Then we also have detection and configuration of your built-in ports. This could be ports such as USB. It could be serial ports, okay, which are kind of primitive these days. You don't really see them very often anymore. Parallel ports, okay. What else do we have? A FireWire, okay, or 1394 is another way of describing those. Could also include, eSATA, okay, eSATA. Kind of running out of room there. But a lot of those different kinds of ports that we have there, your PS2 for a keyboard and mouse, all that kind of stuff is detected by the BIOS. These, again, are things that we don't normally configure. For example, PS2, they're just kind of there. Not really a lot you do with them. USB, you can turn them on or off if necessary. And you can also do things such as giving the BIOS the ability to see it during the boot process. That might be useful because maybe you need to boot from a USB flash drive. This is kind of a good troubleshooting method. In fact, you can create a USB flash drive that has little pieces of Windows on it, so to speak, known as the Windows recovery environment, that you can use for troubleshooting purposes later on. So you could do that. If I turned on the USB port, so that's available during boot, then I can boot to a USB flash drive and then take some troubleshooting methods. Serial ports, that's pretty important. Normally, if you have a serial port, you'll want that to be enabled because there could be certain diagnostic utilities and things that you could run through that serial port. Although with most systems nowadays, that's been ported over to, pun intended, I guess, ported over to USB. USB is very, very flexible and useful that way. Parallel ports, we don't really see those very often anymore, and FireWire and eSATA, which I've already discussed. We also have the ability to detect and configure integrated devices. This can include, but not limited to, certainly, video. So if you have video integrated into the motherboard, then you can configure certain aspects of that, perhaps what it's capable of, for example, or how it caches certain video characteristics, or how those video characteristics operate. For the most part, we don't really see as many motherboards with video integrated into them unless you have specific purpose kind of a system you're working with. For example, a lot of these very, very small form factors that we work with nowadays probably do have video integrated into them, but if it's a high-end system, normally you buy the video card separately. There's also audio, which is very often integrated into the motherboard. It'll detect, and you can configure that as well. You can specify what kind of audio it is, a certain kind of digital, for example, or something else called AC97, which is a different kind of an audio standard there. Network cards. Very often network ports are integrated into the motherboard, so you don't have to buy a separate network card. And in many motherboards, now there's 2 or more network cards. In fact, in mine, right now, there's 2 network cards. And in terms of the configuration of that, I could configure the network card so that it is bootable, for example, so that I can boot to the network card, which really reaches out to some other system on my network and can download an operating system, for example. A very, very handy item there. Also, we've talked about this before, but we use the BIOS to configure the date and time, and you can also use the BIOS to configure power management. Depending upon the operating system that you're running, and for the most part in this A+ exam objectives we're thinking about Windows, then you could hand off most or all of the power management functions to the operating systems because they're generally intelligent enough now to be able to handle that. But otherwise, if you wanted to do it through the BIOS, you could specify whether or not it's capable of various S states, S1, S2, S3, and as we'll discuss that at at some point in the future, that'll identify whether or not the system can go into a low power mode of some type or something like this. And a lot of advanced BIOSes now will kind of do a compromise or an interaction between the operating system and the actual BIOS. Other functions of the BIOS will include things such as hardware monitoring. This is where we identify the temperature of your CPU or inside the case, overall temperatures, or the fan speed. These sorts of things are pretty critical to monitor, especially if it comes to something like overclocking, because when you overclock, what you'll do is you'll apply more juice to the CPU and to memory. When you apply more juice to it, or electricity, is what I should say probably, then it causes this to get hotter than it would otherwise get. So you'd have to more critically monitor the temperature of those kinds of things when you're doing overclocking. And then you can also configure the boot order. Very common boot order would be the first item that you would boot from might be the hard drive. The second item might be the DVD or CD. Third item, oops, that's supposed to be a D. Try that again. And then the third item would be maybe a network card, or a thumb drive, or a USB flash drive. So those are some of the common orders that you might see. Normally with an installed operating system, you do want to keep it at the hard drive, but you might need to at least temporarily switch this so it boots from the DVD first so that you can install Windows. Or if you're installing the operating system from the network, maybe from a server, for example, then you might put the network card as the first bootable item. So this is all very flexible, and you can change that in the BIOS. And then these settings are actually going to be stored, once again, in the CMOS, as I mentioned a little bit earlier. And if you take a lot of effort to custom configure this in just such a way, you certainly don't want the battery to go bad or come loose or something. And then here's a key thing about the BIOS that I should mention. The BIOS really is drivers. And the reason why these drivers are so critical is because these are low-level drivers that give you basic interaction with the components of the system. So basically what this does is allows the hardware to provide a user interface so that you can actually work with what you're seeing there. For example, without the drivers in the BIOS, you can never use the keyboard. That's why the driver, and that's what this driver is here, the hardware is a driver that allows the user to interact with the keyboard, for example, so that you can then press a key to install an operating system and so forth. So these are base level drivers for keyboard, mouse, drivers for the USB ports, for serial ports, all of those sorts of things. And in fact, later on we'll talk about this when we discuss operating systems more and troubleshooting. But for Windows, if you have a catastrophic problem with Windows and you can't properly boot it, you'll very often boot to what we call safe mode. In safe mode, it's really loading very little of its own drivers, at least the own bare essentials that it has. It's very often largely using drivers directly from the BIOS to eliminate Windows drivers as the cause of a potential problem you might be experiencing. And then there's also the POST. This stands for the Power, I forgot to write this in, let me write it in here, Power On Self Test. Okay? The Power On Self Test. And when it comes to the POST, very often on the user side of things, we don't see that all the time anymore because various manufacturers might put a splash screen up over the screen to cover up the POST process. And it might be an advertisement for the company. And I don't know what it's, Dell or somebody like that. But you can also configure the BIOS so that it will reveal the full POST to you and do things such as test the memory. That's what this does, the self-test. Make sure that there is a CPU in the system. Make sure that there is a video driver or a video card or adapter in the system. Make sure that there is memory and that it's properly configured. In fact, for some of the more critical items, if the device is not present or not configured properly, the computer won't even properly turn on. So the POST gives you basic functionality for the base level hardware in the system. Now, it doesn't detect all systems right away. For example, I might have installed, a professional level sound card into my system. Well, that's not critical for the system to power on, not critical for the system to be able to boot up or even to install or to load the operating system. So the POST doesn't really detect that necessarily specifically, although it may detect that there's something in that slot. But certainly it is critical to make sure that at least the bare essentials for the system to be able to properly boot are in place. All right, great. Now, how do we actually go about configuring this BIOS that we've been talking about? To access the settings, this can vary from manufacturer to manufacturer. Some it's a combination of things, like, I don't know, Control F2 or whatever. But for very often, you're going to see that it's one of the following settings most of the time. F2 is very common. In fact, I think it's Dell that uses F2 quite a lot. Delete key is another one, and that's what I use for my own ASUS motherboards. Then there's also the escape key can also be used, and a few other things. It just, who knows? It depends on what the manufacturer says. You'll have to check your documentation, although normally you're also going to see in the very first splash screen for the BIOS, it'll tell you what button to press. The only gripe I have with that is, and I suppose it's an effort for them to get a faster boot process for the user, that message very often just flashes on the screen in a moment, and it's so fast sometimes you can barely even read it, and much less have the reflexes to press the right key at the right time. In fact, sometimes I've had to restart the computer multiple times in order to hit the key fast enough. Maybe I'm just getting slow in my old age or something. Anyway, there's a couple of different levels of settings there as well. One of those is just the basic settings, and we'll see some of those settings here as we go. And then some of the other ones would be advanced settings. And this is where we would do things such as configuring, I don't know, power management, or configuring things like overclocking settings, or the amount of voltage that we're sending to the CPU or the memory. That's part of the overclocking. So there's several different kinds of levels that we'll take a look at there. And then there's also other adapters BIOS. You see, the BIOS that you normally see on a computer when you start it up, that's the BIOS that's included with the computer, but there may be other BIOSes available as well. For example, and you'll see this more often on servers, you may have an adapter in there that's a SCSI adapter, and for that one it allows you to run multiple hard drives off of it in maybe a RAID configuration. Normally you'll have to press something like Control-S or F4 or Control-I or some other combination. Again, it will show you what you need to press, but it also goes by very, very quickly. But part of the BIOS routine is to search for other devices that have their own BIOSes and temporarily pause the system BIOS to allow those other adapter BIOSes to present themselves. Then the user can configure that BIOS. When they're done with that, it will then resume the normal BIOS process. Alright, so what I've done here is I just took photographs of my own computer during the boot process and the post process and all of that stuff, so that I could kind of show you by way of example some of the things we've been talking about. Here it identifies the manufacturer of my BIOS, which in this case is American Megatrends, and you can go to their website here if you want to download any updates. Although I normally recommend that if you want to download any BIOS updates that you first go to the manufacturer's website instead, because they may have something that's been proprietary or added to the core BIOS. In my case, I don't know if it shows it in here, but yeah, there it is, an ASUS. So I'd go to ASUS's website to see if they have any BIOS updates for this particular motherboard. And there's the model that we see right here. Okay. This also tells me the BIOS revision, so that I can see if I need to update the version of my BIOS. There's actually probably more specific information when you actually go into the BIOS and look at the specific settings. And then this tells me the CPU that I've got. This is part of the post. It detected in the post that I have a CPU. This is the brand, and it's a Core i5 CPU. It has this kind of speed, 262.67 gigahertz, for example. And then this is some of the basic settings that we have for that. Here's what I was telling you about earlier, where it'll tell you what you need to press to get to setup. So I need to press the delete key in order to get to setup, and you just need to press that as soon as you can. You can also press in this motherboard. The BIOS has a setting for F8. So if I want to access BBS pop-up, which is actually boot priority settings that I can configure. These are for one-time changes to the boot priority that I might want. For example, if it's normally set to go to the hard drive first, I can hit F8 and instead choose to go to the DVD first. You can also press Alt F2. I don't know, you kind of wrote over that, so let me kind of clear that. Alt F2 to execute the ASUS Easy Flash 2. This allows me to save my BIOS settings, for example, into a set of configuration settings for future use. Or I can update my BIOS, for example. This tells me that I've got my memory installed, the DDR3 memory at 1784 megahertz. It initializes my USB controller. So again, that's part of the post. This is all part of the post. It tells me the total amount of memory that I have installed in this system. And it identifies the USB devices that I have. And again, this is critical to the post because without this, I would not be able to use a keyboard to be able to even access the BIOS settings. It tells me 2 mice, and in reality, I only have 1 mouse, but it detects the other one as a mouse as well, and it kind of works that way. It's a Wacom drawing pad, and that's what I use to make all my little scribbles that you enjoy looking at so much. So that's what that is. 4 hubs, and this allows us to have multiple USB ports, but they don't all get full bandwidth speed. They're split off into hubs. We'll talk more about that later on. And then 1 storage device, that's that's just an external eSATA drive that I have connected that I use for backups. So then we see other things that it detects here, and we can move on. And if I press delete, then I'll be able to get into my BIOS settings. And then one of the screens that you might see, and your screens, by the way, for the BIOS that you're working with, or your customer's BIOS, may be different than this, may be drastically different. But the information is basically the same, and it's intuitive enough, I think, that anybody could eventually find their way around in this. But here's on the main screen in my particular BIOS, by way of example, we see the BIOS version. This might be important to know later on when it comes to updating the BIOS, which I'll discuss in a little while here. Also the build date of it. Here it tells me the kind of processor I've got. An Intel Core i5 CPU, that's 750 series at 267 gigahertz, and there's the front side bus speed. Here's the available memory that we have. So just some basic information there to get started. And then here I've gone to the advanced menu, and with this one, to navigate your way around, you'll just use the arrow keys primarily, arrow and enter, and I'll show you that also in a live BIOS here in a moment. But I've gone to the advanced item here, where we can again see some rudimentary information about the processor, but besides that, it also gives us some additional information, such as the cache that it's using. So it's the level 1 cache is 256 kilobytes. Remember, that's a faster cache than the level 2 or level 3 cache. Here we have 1024 or a megabyte, and then 8 megabytes here for the level 3 cache. And then some other things we see here might relate to things such as for overclocking, for example, there's a ratio that takes place in terms of the megahertz, the clock speed of the processor, which can be multiplied, for example. And then here we see, and this is the ratio here, for example. The ratio right now is 19 times the clock speed, but we could increase that, as you can see right here. And so this just gives us some basic information there once again. Oh, here's another thing you might want to know about. We'll talk about this when we address processors specifically at a later point in time, but the CPU ID might be important because there's a certain thing known as the stepping, which is the version of the processor, the exact version of the processor, and because there are sometimes like little slipstream or incremental or minor updates between processors, even though two of them might look identical and they're in the same box, they may actually be slightly different. So if you need to replace one and you want exactly the same one, you need to know about that. Although that's more important in servers, which might have 2 or more physical processors. Most consumer-level and desktop-level PCs will have a single processor, although it may have multiple cores, like this one does. With most current BIOS, you'll also see a hardware monitor type of an item. Might be named differently in yours. And this gives you one critical number right here, and that is the CPU temperature. Okay, which we can see here is 114 degrees, which is acceptable. Here is 100 degrees for the motherboard temperature, which is, again, certainly acceptable. And then the CPU fan speed, normally it's going to be somewhere between 12, 1300, 1500 RPM, somewhere in that range. We can see that the CPU Q fan, what's that Q fan mean? Well, that's something that's vendor-specific to ASUS, and that's something that they can use to further control and specify the speed of the fan. And then here's another item that's related to that. The CPU fan profile right now is on turbo. So if I overclock to the turbo, which is the highest kind of prepackaged level that I could go to, for example, then it will also increase the CPU fan speed. Here we have a chassis fan. This is just a fan that I've connected to any number of chassis fans that I might have. I don't have this other one connected, but this tells me how fast that one's running. And these, again, are very useful. Notice, by the way, this one looks an awful lot slower, 614 RPM, whereas the CPU is 1400 RPM. Does that mean a problem? No. The chassis fan that I'm running is a big, gigantic fan. It's got to be like 6 inches across. So even though it's running slower, it's going to be moving a lot more air. And some of this, again, is vendor specific. But what we can also see is some CPU voltages down here. This is just to monitor it and see if we're out of spec for these voltages. Normally, they're going to probably be okay, but if you have a power supply that is too small and it's not sufficiently powering all of your devices and motherboard, you might see these sag a little bit and be too low, in other words. Now, as we take a look at another screen here, I do want to point out that the way we access all of these is through these top menu. We just use the left and right arrow keys to move through the different levels of these various menus, and then you would go down to whichever thing interested you. I'm not being too specific about it because they're all different, and what I show you here might not be the same for yours. But in principle, at least, most of these same kind of things will appear. One of the things that you do want to make sure is enabled, especially on motherboards that are running Windows operating systems or Linux, Linux is that you have this ACPI APIC support. That's the Advanced Configuration Power Interface. And APIC stands for Advanced Programmable Interrupt Controller. We'll talk more about those sorts of things later on. But this is very important to have this enabled when you have anything that's going to need to use plug-and-play capability for the system. Most new motherboards and new systems are already set for this to be enabled, but if you're having trouble with device detection, for example, you might want to check and see if someone's fiddled around with this and disabled it. And then you'll also see somewhere in your BIOS something similar to this wording for plug-and-play, and it would say plug-and-play OS. That's probably what you're likely to see. Normally, you'll want to turn this to yes. What that means is it will hand off a lot of the plug-and-play detection to the operating system instead of having the BIOS perform some of those functions. And that certainly is a safe thing to do. This is kind of an old Windows troubleshooting tip, such that if you're having difficulty with plug-and-play device detection working properly, make sure that this is set to yes. And then the verbiage may be similar to this, but different. Basically, what you want to tell the BIOS is that you want your plug-and-play to handle detection of devices. And so in this case, I answer yes to that question. And then speaking of devices, you'll also see some menu item relating to your onboard or integrated devices configuration. And here it'll identify the various devices that are integrated into the motherboard. These would be things that in the past you would have had to add in separately as an expansion card, but which are now integrated into the motherboard, and that's been the case probably for several years now. And so, for example, let me pick a good example here. Well, there are network cards. Realtek LAN 1, I have 2 network cards in this motherboard. They're both enabled. I also set them up for LAN boot ROM. That means that both of these network cards could boot to the network, get an IP address from a server, and then install an operating system from a server, or do something else, maybe troubleshooting or diagnostics from that server. So basically the idea is that I can boot from those network cards. If I've decided to do that here, then I also need to go into the boot order and make sure that they are part of the boot order. In some BIOSes, you can also just specify or press a special key during the boot process so that as long as this is enabled here, even if the network cards are not part of the boot order, you can still boot to the network card. Network port there. And then here's our FireWire controller that's enabled, and you see some of the other kind of self-explanatory items there as well. But basically the idea here is you want to enable these items in almost every situation. Rarely would you disable them. The only reason I think that you might want to do that is, for example, if I had a serial port, okay, and it was using a specific set of resources here, but maybe I had some other kind of an expansion card which also insisted on using these same resources. And in this case, I would not disable that, because notice that there's not a disable or enable item there, but I could change these resources to use different resources. So that's the way you can kind of fiddle with these things to make them compatible with other devices, for example. Oh, one other thing here. I forgot to mention this. The onboard USB 3.0 controller. This is not part of the exam objectives for A+, because it only goes up to USB 2.0, but USB 3.0 is the newer and fastest version of USB, and this particular motherboard, which is fairly new, has a capability for USB 3.0. Just a few moments ago, I was talking about setting the boot device priority. We were talking about network cards, I think, in specific there. But here, we have some common settings for this sort of thing. For example, the boot device priority is the first boot device is actually a removable device. I probably need to change the order of this. This is a USB flash drive, just a thumb drive that I've got. It doesn't have any kind of operating system or bootable files, so it's going to get ignored in the boot process, and it's going to skip right down to the next item, where I'm using RAID 10 for my 4 hard drives that are installed into this system. So that's the actual first bootable device that actually appears. Now, is it going to help anything if I just shift this one up so that the RAID devices are first? Could possibly, just for a brief moment, because what will happen is during the boot process, it'll first scan that removable device to see if it has anything that's bootable on it. If it doesn't, it moves on to the next one. So I might be losing a second or two while it scans for that item. Then you can see the CD-ROM, is here as well as my network devices that we see down here as well. So that's basically these items. If you wanted to change the order of these, for example, maybe I wanted to boot from the 4th boot device first, then you would just press the plus key on the numeric keypad, and that moves it up in the order, or minus would move it down. And that's pretty common across many versions of the BIOSes, so that's probably what you're likely to see. We also have some other specific boot settings configurations that we can look at. One of those would be the quick boot. You see, normally during part of the post, it will scan and detect and test your devices in the power on self-test. You can enable quick boot so that it will bypass certain tests that probably don't really need to be run every single time unless you suspect some kind of a problem. For example, what will happen with this enabled is it will not count up all of the memory and test it as it goes. So if I were to disable this, then and we booted the system, we would see it counting the memory and testing it one bit at a time, for example, 1 byte at a time. Also, we can do the full screen logo. This is disabled by default. This will just help to not baffle users because there's a lot of verbiage that goes flying by the screen. This just conceals it and puts up a company logo, or in this case, actually an ASUS logo, I think it is. You can also specify what takes control of the display. This is forcing the BIOS to work with the ROM display mode. That can again vary from one machine to the next. The boot numlock you can see here, and other things that we see as well, which I think fairly well explain themselves. Although this one down here, post-state LEDs. If you look at the motherboard, then there are LEDs on there that can be useful for diagnosing various problems that you might have, and the LEDs will either flash in a certain order or certain ones will be on, identifying problems. Then you would have to look at the owner's manual for this motherboard to be able to interpret what those LED codes mean. Let's go back to storage here. Remember a little while ago I talked about storage in this system, and then I'm using RAID 10. What we have to do is I had to go to the main menu we see here under the storage configuration, and I had to specify how to use the serial ATA ports that are on the motherboard, because they can all be just used individually, so that I would connect separate drives that didn't really have one relationship to one another. However, if I configure them as RAID, then that will give me the opportunity in a different menu later on to configure RAID 5 or RAID 1 or RAID 0 or RAID 10 like I'm using right now. And then if I do enable that as a RAID devices for my serial ATA connections, then it will also expose this option to me so that I can use this Intel Matrix Storage Manager, which has its own kind of a BIOS. And what I would have to do here is I'd press Control-I to enter that configuration utility. You can say I've already configured it, but what this would allow me to do is to go through another series of menus to construct my RAID array and tell it how I wanted it to look, how much storage I wanted it to use, and so forth. And then once I press Control-I, this is the actual menu that it takes me to, and you can see some of the various options that appear up here at the top, and I would just press the number corresponding to what I wanted to do. Again, yours will probably be different than this, but most of them have the same concept, and so you should be able to pick up what it's trying to tell you here. And we will again talk more about this type of storage at a later point in time. Now, it may be that certain of these BIOS settings, you don't want the user to go in there and fiddle around with those things. So somewhere in your menu system, what you can do is to set up a supervisor password. And this means that only people that know the password will be able to type it in during the boot process, and then they'll be able to enter the BIOS and make configuration changes. And you can also change user password. What's the difference between the two? Well, user password is necessary to type in just to be able to boot the system. In other words, whoever sits at that desktop every day needs to know that user password in order to get anything done, in order to start up their computer. The supervisor is the only person, though, that can make changes, and these can be totally separate passwords. In fact, they should be separate passwords. One thing to keep in mind, though, is that if somebody's technically savvy, all they'd have to do is to reset the BIOS in order to be able to clear these passwords, and that can normally be done by jumpering a couple of pins on the motherboard. Or by taking out the battery that we talked a few times about, which would then also reset all the CMOS settings. So this is rudimentary security, but it might be helpful in certain situations where you're concerned about the user changing the BIOS settings. Now, depending on your manufacturer, they may also have the ability to save your BIOS settings. So, for example, let's say that the way my computer is running right now is just excellent. Everything's very stable. I like the way things are running. Plug and play is working fine. you know, it's pretty much a happy day right now. If that's the case, I probably ought to think to go into this and to save my current CMOS settings for this motherboard and save it to the file system somewhere. That way, if I need to retrieve them, maybe I've made some overclocking settings or tweaked something, maybe over-tweaked something, and the system's not stable anymore, but I want to get back to a known good configuration. Well, I could just go back to whatever my CMOS was that I stored. And then here's where I might have actually saved those settings. By the way, again, this will have a different look and feel depending on the vendor. Some of these also offer utilities from within Windows where you can also save the BIOS settings. And then here you can see that I went into the AI tweaker settings. I don't actually use this. I actually use the utility from within Windows to be able to tweak this. I could go in here individually though, and I could change, for example, the CPU ratio to make that faster, or I could change the clock frequency and any number of different items that we see down here. These are going to be normally very highly advanced settings that only somebody that really knows overclocking would probably want to get into. Otherwise, you might want to use the utilities that appear from within Windows that often are available from the manufacturer. And that will automatically tune this. In fact, that's what I did. I just set mine up so that it would automatically tune the system, and it synchronizes the memory with the CPU and gives it a relatively stable profile, but at the same time is pretty highly overclocked. And so I just kind of use the automatic method. And that, by the way, is similar to what we see here, so that you can start the auto-tuning item here from within the BIOS as well. Just again, using the Windows utility might be simpler. But once you do this, it might send you into an unstable condition. When you overclock, especially if you push it like to the max, then you might be more likely to see system lockups or blue screens or other catastrophic failures. And if that's the case, then the system might spontaneously reboot, and you might see a screen something like, I think I got one here. There it is. Something like this right here, where it was telling me that it had a problem with overclocking. Okay, overclocking failed, and it asked me to re-enter setup and reconfigure the system. At that point, then, it will stop right here, and it will ask me to press F1 to run setup, or to F2 to load the default values. You see the way the motherboard ships, it has some relatively stable default values that are pretty reliable. And so I could just hit F2 and go back in and start the whole thing all over again. Or if I was pretty sure I knew what this change was that I made that created this problem, I might press F1 to go to setup, and then go ahead and make that change. Now then also, as with my BIOS settings, I can also save my overclocking profile configuration. So if this configuration that I'm working right now seems to be very highly performing, but it does not seem to have any risk of instability, I might save it. And you can see here I did. I just called it James Turbo. Oh wow, that sounds kind of cool. Now I wish that was my first and last name. Hello, I'm James Turbo. Although it's probably more likely James Nerdo. Anyway, so I save this here, and then I can again return it to a kind of a known good configuration at a later point in time if I want. Now then, here I just went ahead and decided to boot to a BIOS. Now what I'm using here is actually something called VMware. Let me show you what I mean by this. There's a product here, I'm just going to move this into the window so you can see, a product called VMware Workstation. Microsoft has a similar thing in their servers called Hyper-V in Windows Server 2008. Anyway, what this allows me to do is to use multiple operating systems within one. So right now I'm actually running Windows 7, but I could also go to Windows Server 2008 Data Center. This one's not started up. I could go to a Vista client. I could go to an XP client, which is where you see I am right now. So I could run any number of operating systems from within Windows 7 in this case, and that's very useful for testing and very useful for things like, well, what I'm doing for training purposes and things like this. So what I've done here is I've booted that system, and I pressed, I think it's F2 in VMware to access the BIOS settings. And then from this point, now you can see that I can use my arrow keys to move up and down all of the various items. It tells me, let me go back down here, what my memory is, how much memory I've got available. Let me go over to the right. My advanced settings. So this is just kind of the same idea that you'll see in your normal actual physical machines as you're working with these items. So I could go to my I/O device control, and I could enable or disable things such as serial ports, parallel ports, floppy disk controllers. We don't really see those too much anymore. If I wanted to go back out of the menu, I'd press escape, which is what I just did, to get back to this location here. So, I could do other things such as configure error correcting code memory. We'll talk more about memory a little bit later on. Here's the supervisor and user passwords that, once again, I could configure. And then as I arrow over to the right, we see again that I can adjust the different types of boot devices I have. For example, right now, it's going to boot from the removable devices. If I want to go to the hard drive first, then I'll just use my plus key, and you can see here that it then ups that in the boot priority. And then once I'm done, I can exit saving the changes, exit discarding the changes, and so forth. Now let's talk here also about troubleshooting the BIOS. We talked about this a little bit earlier, but if I've been tweaking with the BIOS settings and saving all kinds of crazy stuff for the CMOS, maybe I've been doing some overclocking or something like that, and now the system doesn't seem to work right or it's causing some frustration. Well, one of the safest things you can do is to go back to a known good configuration so you can reset it to the factory default, which is normally going to be the most stable and reliable, although it might not be quite as speedy as, like an overclocked setting or something like this. The other thing you could do, as I mentioned earlier, is to save the settings that are a known good settings, and then you can later restore those settings so that you go back to a known good configuration that way as well, if the default settings are too rudimentary for you and you want to go back to a saved setting that worked well before. You can also check out BIOS updates, which you can sometimes do. There's been a number of different ways to do these in the past. In the old days, you had to replace the whole the whole chip. Nowadays, we can actually just download a file and then update it this way. I'll show you that here in a moment. You can also work with some postcards, but before I get down to that, let me show you about some of these things here. I've got a little utility here from ASUS, which kind of exemplifies some of these things that I've been talking to you about. So, for example, if I wanted to save my current BIOS settings to a file, because I know they're known good settings, then I could just use their little utility here, and I would say James BIOS, something like this, and I would just save it somewhere. I'll put it in C for now, but I'd find a kind of a permanent location to put that in. And then later on, if I wanted to retrieve that then I would do that here as well. And for those kind of purposes, I would then update the BIOS from a file. I can also update the BIOS from the internet or download the BIOS from the internet and then update it from a file later on. Okay, that's kind of the thing that I've done here. You can also check your BIOS information to see what version of the BIOS we're running. See, I'm running 0501. I happen to know that there's actually a more current version than that, which I've already downloaded. So I could update the BIOS from a file here then, and having done that, then I'll click on Next, and then I can go back here to my desktop. And if I do that, then here you can see I've downloaded the latest version, which is 0609 ROM. I can open that. And then what it would allow me to do is, oops, it switched to the other screen there. Let me put it back over here. Then it would do is it would identify some of this information that's the current version, the version that I wanted to update to. And then it could also clear the CMOS checksum to load the default BIOS settings. This would ensure that the updated BIOS would be in its most stable situation. However, that might also be a little disruptive because then I'd have to start from scratch and, reconfigure all of my BIOS settings. As a general rule, we don't usually update the BIOS unless we're experiencing some kind of a problem or there's a new feature in the BIOS update that we're aware of. Normally, when you go to the vendor's website, it'll identify the features of the new BIOS. Most of them have to do with bug fixes of some type, and generally you don't want to update unless you're experiencing that specific bug fix. Now, if you're still having problems, you might want to get a postcard. No, this is not one of those things you get from the gift shop at band camp and send to your friends letting them know what a good time you're having. This is one of those things that you'll actually plug into your computer, and it's able to do a pretty thorough diagnostic of your system. And I'm going to exhaust all of these, but I'll just show you some sample products that you could take a look at there. For example, actually let me go to this one first. This is kind of a rudimentary one. It's probably, I don't know, 60 bucks or something like that. And it just has, I don't know if you can see it, but there's 2 green LEDs on here. And this will give you more specific information about the hardware during post. Actually, it is 6788, okay? And this is from JDR.com. So then it'll have a legend which will identify what the flashing, symbols mean and everything like that. This one's going to be much more specific and much more expensive possibly here as well. I'm not sure. I haven't really priced these out recently. But what these will do is they'll plug into a PCI Express slot, and then it'll have a serial port out of the back of this. Let me just actually click on it so I can... Ooh, it says the link does not exist. Okay, that must be a really good product there. Let's try this one. See what that does. Anyway, so we see here just a little bit more information about it. You can custom configure the kinds of things that it will test and the kinds of things it'll do with these dip switches that we see here as well. But again, these are very specific devices that will give you in-depth information about your system. And then if it turns out that your BIOS is just totally messed up, maybe the chip itself is corrupt somehow, maybe somebody sent an electrostatic discharge through it or something like that, you can go to this site, biosman.com, and this company here will send you new BIOSes. Okay, and they're supposed to be tested and everything, and they'll also send you a tool here if you need it to extract your BIOS. So just check these folks out here as well. They also have their own postcards as well if you want. But just check those things out for more involved diagnostics with BIOS. And like I said before, you can use that Postman link if you want to replace the BIOS chip. In this nugget, we discussed the BIOS. The first thing we did was you talked about the various terms, such as ROM and BIOS and CMOS, so you could kind of understand how all those relate. Again, the BIOS is kind of programming on a chip, and that chip is read-only memory. And then when you make changes to the BIOS settings, you'll store that in the CMOS. Then we also took a look at BIOS functions, the various types of things that it does, such as the fact that it detects your storage, the fact that it allows you to configure whether or not you want to use RAID and the like. We took a look at actually configuring the BIOS through some example screens primarily, but remember that when you make changes to the BIOS, you will save those in the CMOS. And then if you need to troubleshoot, what you can do is also back up your existing known good settings and then restore those at a later time. We also saw that you can download updates from vendors, and you can also even replace the entire BIOS if necessary. Well, I hope this has been informative for you, and I'd like to thank you for viewing.